GPS interference refers to spoofing or jamming, two types of deliberate cyber attacks on global positioning system signals, which disrupt or deceive vehicles' navigation systems. GPS jamming, also known as GPS intervention, involves a device jammer emitting strong radio signals on GPS frequencies in order to overpower weaker signals. This disrupts the functioning of GPS systems by rendering receivers unable to determine location or time. GPS spoofing involves a device transmitting signals on the same frequencies used by GPS satellites, overwhelming or blocking the GPS receivers from acquiring or maintaining the right satellite signals. Unlike jamming, which disrupts signals entirely, spoofing deceives the receiver into trusting false data. The risks of GPS interference are real and alarming. Spoofing can cause a pilot to misjudge the aircraft's position, increasing the chance of collisions with terrain or other aircraft. For ships, the consequences of loss of situational awareness include groundings or collisions, disrupting entire maritime operations. Most often, countries with advanced electronic warfare capabilities and involved in an active conflict are responsible for GPS interference. For aircraft, spoofing is one of the primary risks of being in the airspace of countries in war. This is one of the reasons for that airspace being avoided by all aircraft during war. We immediately avoid these areas as a preventive measure. Aircraft experiencing GPS spoofing might have to rely on alternative navigation systems. Inertial navigation systems are the primary backup. These use gyroscopes and accelerometers to track the aircraft's current position based on its last known location. VHF omnidirectional range and distance measuring equipment provide ground-based radio navigation, allowing pilots to further cross-check their position. Shipping companies are adopting multi-constellation global navigation satellite systems to mitigate against GPS interference. These use navigation systems of multiple countries to counter the digital threat: the United States' GPS, Russia's GLONASS, the European Union's Galileo, and China's BDAO, among others. The Indian military has deployed the Indigenous Navigation with Indian Constellation, NAVIC, developed by the Indian Space Research Organization. NAVIC is designed to provide precise positioning and timing services across India, and up to 1,500 km beyond its borders. During the 1999 Kargil War, India's request for the use of American GPS for information about positioning, timing navigation of hostile forces was denied. Likewise, in 2009 and 2012, India's BrahMos missile failed to hit targets in trial operations as the US shut off GPS satellites without any warning. Such incidents necessitated the need for NAVIC. Its resilience and reliability were ably tested during Operation Sindoor.